All right, so this is an accompaniment to the eye structure. If you have seen that video or if you already feel like you know the structure and you just want to know about accommodation, you can watch this. So, accommodation, I've already written the definition here. It's the process by which the lens changes shape to focus light. And so the idea is that uh, you need, in order to focus the light onto the retina, the back of the eye, you need to make sure that that the light waves are kind of coming to a point at the on your retina. And so in order to do that, the lens is what's responsible for making sure that happens. And if it doesn't work correctly, this is why people need glasses. So anyway, so the idea is that when you look at an object that is far away, I mentioned this before, I talked about it some in the eye structure, but the idea is that the lens, right, is held into place by these suspensory ligaments. All right, and then these suspensory ligaments are attached to the ciliary muscles. And so when you look at an object from far away, the idea is that the light waves are basically coming in almost straight. And so you want them to be refracted really, um, onto the back of the eye and focus it. Uh, but the amount of bending that the light waves need to do is not a lot. So what happens is the idea is that the ciliary muscles are relaxed at this point. So the ciliary muscles relax. And what that does is when they relax, the suspensory ligaments are actually pulled tight. So you can say that they're taut or you can say that they're pulled tight. You cannot say that they are contracted. They are not muscles, right? Ligaments do not, the only thing that you do not use the word contraction unless you were talking about muscles. So the suspensory ligaments, I would say are taut. If you don't like that word or you don't know that word, you can just say they're tight. That's okay. All right. And as a result, because of these things, the resulting effect is that the lens is thinner, right? So you can see it's not super fat right here. I've drawn it fairly thin. All right. Now, so then what happens when you look at something near? So the idea when you look at a near object, you have the same thing, but now rather than coming in directly, the light waves, so if this is my object, the idea is that the light waves are kind of coming in, they're more spread out. And so in order to make sure that you're going to refract the waves in a way that you need them to, the lens needs to be thicker and rounder. Okay. And so the way that you do that is, so sorry, I've still got my suspensory ligaments here and I've got my muscles here. You guys know I can't draw, so that's it. Okay, because now if you can see, the idea is we still need these light waves to be refracted like this, and so you see that the angle of refraction needs to be greater here than it is up here. So what happens is the ciliary muscles then contract, and by contracting, what that actually does is it relaxes or loosens the suspensory ligaments. So we say the suspensory ligaments, sorry, you can say are slack. That's the word I would use. Again, if you're not comfortable with that word, you could say loose. All right. Um, and because of these two things, the end result is the lens, you could say, is thicker or fatter. Please make sure you do not say it's bigger. It's not bigger. I know these aren't drawn to scale. It doesn't actually increase in size. What it does is it just kind of squashes down and gets thicker. All right, so that it can refract the light more. So that's accommodation.